Hello dear students. Today we will continue our lecture series for class 9th, and today I will just continue from acceleration. As we all know that acceleration is the rate of change of velocity. The rate of change of velocity is called acceleration, and students, it is denoted by letter A. And acceleration is called to change in velocity upon time taken for the change. So here acceleration is equal to change in velocity upon time taken for change. Now students, next is, now see, students, acceleration is regarded as positive if velocity of the body is increasing, and acceleration will be negative if velocity of body is decreasing. And students, when velocity of a body will decrease with time, it is known as retardation or negative acceleration. So students, hope this is clear to you all. Now students, next we will see unit of acceleration. Next we will see unit of acceleration. Unit of acceleration. So students, unit of acceleration, unit of acceleration, it is simply equal to unit of velocity, unit of velocity upon time interval, upon time interval. So unit of velocity is how much? It is meter per second, as we all know, meter per second, and unit of time is second. So students, after simplification, it will become meter per second square. This is the unit of acceleration. And students, in CGS system, it is equal to centimeter per second square. Because students, in CGS we measure length in centimeter. So this was all about the unit of acceleration. Now sir, next is uniform acceleration. Next is uniform acceleration. Now friends, we will see what is uniform acceleration. So students, when the body travels in a straight line, here students, we are studying about the motion of a body in a straight line. So students, when a body travels in a straight line and velocity of a body changes uniformly at the same rate, if the velocity of the body is changing uniformly at the same rate, then the acceleration is said to be uniform or constant acceleration. Now you can see here, this car, velocity is 5 meter per second at t equal to 0 second. Velocity is 10 meter per second at t is equal to 1 second. Now students, for these two, we will calculate acceleration. So students, acceleration is how much? Change in velocity upon change in time interval. Now students, what is here change in velocity? See, velocity is changing from 5 to 10 meter per second. So your change in velocity is 10 minus 5. And how much is time? Time interval for change? 1 minus 0. So here, how much we will get? We will get 5, and unit will be meter per second square. So again, here we are getting acceleration is equal to 5 meter per second square. Next, students, we will calculate for car second and third car. Second and third car. So see how to calculate it. So students, if you will see here, second car has velocity 10 meter per second, time is equal to 1 second. Third car has velocity 15 meter per second, time is equal to 2 seconds. So students, calculate here change in velocity. Acceleration is equal to change in velocity upon time interval for change. So what will be change in velocity? Here, the velocity is changing from 10 to 15. So 15 minus 10. 15 minus 10. How much is time interval for change? 2 minus 1. So here, how much we will get? 5 upon 1, again 5 meter per second square. So students, here we are getting velocity acceleration again 5 meter per second square. For first to second car, the acceleration was 5 meter per second square, second to third 5, and if you will calculate for third to fourth, it will again come out to be 5 meter per second square. In this way, your acceleration is coming out to be constant. So this acceleration is known as uniform or constant acceleration. I hope this is clear. And students, if you have any doubt, then you can ask. So now we will move forward. Now, student, next is non-uniform acceleration. This was all about uniform acceleration. Next is non-uniform acceleration. Now, student, next non-uniform. See, what is non-uniform acceleration? Now, friends, if a body travels in a straight line and its velocity increases or decreases by unequal amount in equal interval of time, then the object is said to be non-uniform acceleration. If velocity is increasing or decreasing by unequal amount, suppose you have velocity 3 meter per second, time t equal to 1 second, next 5, next 9, time t equal to 2, 3. Time is equal now. How much is difference? 1 second. But here velocity is increasing in an unequal amount. So students, this is of, if you will calculate here acceleration, then here students, your acceleration is come out to be variable, and this is an example of non-uniform acceleration. I hope it is clear. So now next. Now next is students, acceleration due to gravity. This is also very important concept. If you will understand it, then it will make your life of physics simple in when you will reach in grade 11th. So now acceleration due to gravity. Now, since what is acceleration due to gravity? We will see. See, when a body falls freely under gravity, suppose there is a body and this body is falling freely under gravity, the acceleration produced in the body, if a body is falling freely under gravity, then there will be acceleration produced in the body due to Earth gravitational attraction. Because Earth has gravity, so it will. So due to gravity, this body will feel acceleration due to the Earth's gravitational attraction, and this is called acceleration due to gravity. In simple word, the acceleration produced when a body falls freely under gravity due to Earth's gravitational attraction, that acceleration is called acceleration due to gravity. And students, your acceleration due to gravity, it is denoted by symbol small g. It is denoted by symbol small g. Now, students, suppose that when a body is falling down, then what is happening here, students? Its velocity will increase with time. Its velocity will increase with time. So students, in this case, we will take our acceleration due to gravity as positive g or plus g. Now students, suppose body is moving vertically upward. Body is moving vertically upward. Then what will happen? Its velocity will decrease with time. Its velocity will decrease with time. So here students, in this case, we will take our g as minus g. And students, and it is called as retardation. It is called as retardation because it is negative acceleration. Because here your acceleration will decrease, so it is called negative acceleration. Now, students, if you will see the average value of g, what is average value of g? That is acceleration due to gravity. Now, students, average value of g is 9.8 meter per second square. 9.8 meter per second square, or nearly approx we can take 10 meter per second square. 10 meter per second square. And now, students, the value of g, it varies from place to place. For moon it is different, for earth it is different. So students, it will vary from place to place. Now, students, suppose that if a body is falling freely under gravity, suppose that a body is falling freely under gravity, then students, what will happen? Its velocity will increase at a rate of how much? 9.8 meter per second square. Its velocity will increase at a rate of 9.8 meter per second square. That is, if the body will start from rest, then after 1 second, its velocity will be how much? 9.8 meter per second. Now, students, after 2 seconds, how much its velocity will be? 2 into 9.8. It will be how much? It will be 2 into 9.8, 19.6 meter per second. After 3 seconds, just multiply 3 into 9.8. It will be around 29.4 meter per second. Similarly, students, if a body is projected vertically upward, then what will happen? Then what will happen for G? We will see. Suppose, students, here body is projected vertically upward. Then what will happen? Now, students, its velocity will decrease at a rate of 9.8 meter per second square. Because acceleration is what? Change in velocity, rate of change of velocity. So if a body is projected vertically upward, then what will happen? Its acceleration, its velocity will decrease at a rate of 9.8 meter per second square. Suppose that, students, if a body is projected vertically upward and with an initial velocity, the initial velocity of body is how much? 49 meter per second. The initial velocity of body is 49 meter per second. Now, students, what will happen? After 1 second, its velocity will be how much? After 1 second, its velocity will be how much? Its velocity will decrease now when the body is projected vertically upward, and its velocity will decrease at a rate of 9.8 meter per second square. So its velocity after 1 second, it will be how much? 39.2 meter per second. After 2 seconds, its velocity will be how much? 29.4 meter per second. I hope it is clear. Because, students, if a body is projected vertically upward, then what will happen? Its velocity will decrease uh, at a rate of 9.8 meter per second. Is this clear? That's it. So this is all about acceleration due to gravity. Hope it is clear to you all. Now, friend, next is now, friend, next we will go for some numerical problems. So let me upload that file. So this was all about acceleration. Next, we will go for some problems based on velocity, acceleration, speed, distance. So now, so students, first we will see problem number 5. What is problem number 5? We will see. See, a train takes 3 hours to travel from Agra to Delhi with a uniform speed of 65 km per hour. You have to find the distance between the two cities, and the answer is given in kilometer. So you have to calculate the answer in kilometer. So students, here, as we all know, let me proceed for the solution. Speed is equal to distance upon time. distance upon time. And students, speed is given 65 kilometer per hour. Distance is, you have to calculate distance, and students, time is given 3 hours. So here distance will be how much? 65, and write the units also, because if you are a beginner in physics and the numericals of physics, then write the units also, because in this way you will not commit mistake. Hour and hour will cancel. So distance will become 65 into 3 ja, 5 3 ja 15, 195 kilometer. So distance you will get 195 kilometer. So this was all about the first problem. Now we'll see for next. Next is 6. A car travels first 30 kilometer with a uniform speed of how much? 60 kilometer per hour. And then next 30 kilometer with a uniform speed of 40 kilometer per hour. You have to calculate the total time of the journey and the average speed of the car. So students, we will calculate time separate. So see, first, what is happening? A car travels first 30 kilometer with a uniform speed of 60 kilometer per hour. So we'll apply here the formula of speed, distance, and time. So what is the speed is equal to? Speed is equal to distance upon time. Let it be S1, T1, and T1. And what is given in the problem? Distance is 30 kilometer and speed is 60 kilometer per hour. 60 kilometer per hour, which is equal to distance is how much? 30 kilometer, and time you have to calculate. So here, friends, time will become how much? Time is equal to 30 kilometer upon 60 kilometer upon hour. So here, friends, it will be 1 upon 2 hour. So here you will get half hour. So this is time for first motion. Now, friend, next in the problem they are saying next 30 kilometer with a speed of how much? 40 kilometer per hour. Next 30 kilometer with a speed of 40 kilometer per hour. So here S2 is equal to D2 upon T2. So it will be how much? Speed. Second speed is given 40 kilometer per hour. And distance is given how much? Distance is given again 30 kilometer. And time T2 is given. So here time T2 is equal to how much? 3 upon 4 hour. If you will calculate, it will come out to be how much? It will be 3 upon 4 hour. And now, students, you have to calculate total time here. Students, you have to calculate total time. Total time I am denoting by T. T is equal to T1 plus T2. So it will be how much? Half plus 3 upon 4. And both are in hour. And students, we want our answer in minute. So 1 hour has 60 minutes. So here it will be how much? 4. LCM will be 4. So 2 plus 1. It will be 3 upon 4 into 60. Is this clear? 1 hour has 60 minutes. So 4 it will be how much? 4 15 and 15 3 ja 45. 45 minutes is the answer. Let me check. Sorry, matching or not. So it is coming out to be 75 minutes. Wait. So what you can do here, if here it is half hour now, so here it will become 30 minute. 30 minute. And students, here 3 upon 4 hour. Calculate separately. 3 upon 4 into 60. It will be how much? 23 just 15 3 just 45 minute. 45 minute. Add then 45 minute and 30 minute. 45 minute and 30 minutes. Time is equal to 45 minute and 30 minute. 30 minute. So it will be how much? It will be total 75 minutes. We have got. So now next. Now next we will solve problem number 7. See what is problem number 7? So students, I think, oh wait, there is one part left. 6 and 6 second part. What they are saying? They are saying to calculate the average speed of the car. So what is how to calculate average speed of the car? Average speed is equal to students total distance, that is d1 plus d2. They are two distance upon total time, that is t1 plus t2. So how what is total distance, students, here? 30 plus 30, 60 kilometer. And how much total time is here? Half plus 3 upon 4. Half plus 3 upon 4 hour. So here, friends, how much it will become? 60 kilometer upon 2 plus 3, 5 upon 4 hour. So here, friends, 60 into 4 upon 5 and 5, 12 ja 60, 12 into 4, 48 kilometer per hour. So this is the answer, 48 kilometer. So this is the second. Now next, 7th problem. Next is students 7. In 7 they are asking a train takes 2 hours to reach station B from station A, and then 3 hours to return from station B to station A. The distance between the two stations is 200 kilometers. You have to find the average speed and the average velocity of the train. So students, we'll proceed for the solution. So students, here we have to find the average speed of the train. And we know average speed is equal to average speed. It is equal to total distance upon total distance upon total time. Total time. Now, how much is total distance here? See, the distance between the two stations is 200 kilometers, and the train is taking 2 hours to reach from station B to A, and then 3 hours to return from station B to A. Is this clear? So here, students, how much will be total distance? See, 200 plus 200. So here, students, total distance will be how much? 400 kilometer. 400 kilometer. And how much will be total time, students? Total time will be 3 plus 2, that is 5 hours. And students, if you will calculate this, it will come out to be 80 kilometer per hour. That's it. Now, students, in second part, they are asking to calculate average velocity. Average velocity. So students, how to calculate average velocity? Average velocity, it is equal to total displacement upon total time total time upon total time total time. But students, here in this problem, if you will see here, a train takes 2 hours to reach station B from station A. So here train is reaching station B from station A, and also train is returning from station B to station A. So here student, initial position and final position are same. So here displacement will be how much? It will be 0. Here displacement will be 0. So here students, if your displacement will be 0, then what will happen? Your average velocity, it will come out to be 0. Your average velocity will be 0. So this is the solution of this. Now next, eighth problem. Problem number 8. In eighth, what they are asking? See, a car is moving on a straight path and covers a distance of 1 kilometer due east in 100 seconds. You have to calculate speed and velocity also. You have to calculate speed and velocity. So students, we will proceed for the solution. You have to calculate speed and velocity. So here students, speed will be equal to how much? Distance upon time. So here, how much is distance? 1 kilometer, and time is 100 seconds. So 1 kilometer is distance, time is 100 seconds. Convert kilometer into meter, 1000 meter, and time is 100 seconds. So here students, it will be speed will be how much? 10 meter per second. So here speed is 10 meter. Now next. Now student, next you have to calculate velocity. So students, velocity is how much? Velocity will be how much? Displacement upon time. Velocity is displacement upon time. So your displacement is how much? 1 kilometer east. Time is how much? 100 second. And if you will calculate it, velocity will be 1000 meter east. Time is 100 second. So here your velocity will become how much? Velocity will become 10 meter per second in east direction. So this is the solution of this. Now friends, let me upload next file. There are lots of problems to solve, and you should solve by yourself also, because it will boost your confidence if you will solve by yourself. Now next, problem number 9. See problem number 9. See, from what they're saying in problem, a body starts from rest and acquires a velocity of 10 meter per second in 2 seconds. You have to find the acceleration. So students, here a body is starting from rest. Here a body is starting from rest. Suppose A is the rest position, and what they are saying, they are saying that the body is acquiring a velocity of 10 meter per second in 2 seconds. 10 meter per second in 2 seconds. Per second in 2 seconds. So here, students, your initial velocity is 0 because body is starting from rest and body is acquiring a velocity of 10 meter per second in 2 seconds. So your final velocity will be 10 meter per second. Now, students, here you have to calculate the acceleration. So, students, acceleration is, we denote acceleration by symbol small a. Acceleration is equal to change in velocity. And here, students, what is change in velocity? V minus u, that is final velocity minus initial velocity upon time taken for change t. So, students, this formula you have to remember, and this is very important. Based on this formula, you will solve lot of problems. So here, friends, we will substitute all the values here. Acceleration A is equal to 10 minus 0. Time is 2 seconds. Right here, unit also, because you will not be confused. Meter per second and second. So here, friends, you will get 5 meter per second square. This is your acceleration. So in this video, it's all. Now, next, students, next same type of problem. See, a car is starting from rest and acquires a velocity of 180 meter per second in 0.05 hour. You have to find the acceleration. So again, apply the same formula. So we'll apply problem number 10. Acceleration A is equal to final velocity minus initial velocity upon time. So what is final velocity here? 180 meter per second. Initial velocity is 0. So it will be 180 meter per second. Time is how much? 0.05 hour. Now, students, we will convert hour into second. So here, students, we will write as it is. A is equal to 180 meter per second upon 5 upon 100 into 1 hour has how much minutes? 60, and 1 minute has 60 seconds. So it will be 60 into 60 second. Now, friends, calculate it. 0, 0. In this way, you have to do the calculation. I'm just showing you the trick of easier calculation. 630, 180, and 6 5 ja 30. So, students, it will be how much? 5 upon 5, and 5 upon 5 will be how much? 1. So here you will get 1 meter per second square. I hope answer is matched. Yeah, 1 meter per second. Now next, 11th problem. See, what is 11th problem? We'll see. A body is moving vertically upward and its velocity changes at a constant rate from 50 meter per second to 20 meter per second in 3 seconds. What is its acceleration? So, friends, we will calculate it. So, see, a body is moving vertically upward. It means its velocity will decrease. So, here, friends, you will get retardation. You will get negative acceleration. So, is this clear? So, here, friends, if you will see here, what is initial velocity? 50 meter per second. This is initial velocity. What is final velocity? It is 20 meter per second. And what is time? It is 3 seconds. So apply the formula. A is equal to how much? V minus U upon T. Now, V is how much? 20 and U is 50. So 20 minus 50 will be how much? Minus 30 meter per second. And time is how much? 3 seconds. So your acceleration will come out to be how much? Minus 10 meter per second square. So in this way, you have to solve the problem. So this is very simple. Just you have to see what is our initial velocity and final velocity and apply the formula, this formula. A is equal to V minus U upon T. And you will get your correct answer. This was the solution. Now next is 12th problem. See, what is 12th problem? Problem number 12. 12th. A toy car initially moving with a uniform velocity of 18 km per hour and comes to a stop in 2 seconds. Find the retardation of the car in SI unit. So see. So students, what is initial velocity here? 18 km per hour. Initial velocity is, next problem. Initial velocity is how much? 18 km per hour. 18 km per hour. Is this clear? Initial velocity is 18 km per hour. And students, what is final velocity? Initial velocity is 18 km per hour. What is final velocity? Final velocity is 0 because it is given this problem. Because what is happening here? A toy car is initially moving with a uniform velocity of 18 km per hour and comes to a stop in 2 seconds. Comes to a stop in 2 seconds. So what is time here? 2 seconds. Now apply the formula. A is equal to how much? V minus U upon T. 0 minus 18 km per hour. Time is how much? 2 seconds. Now friends, here we need our answer in meter per second square. So what we will do here? We will convert kilometer per hour into meter per second. So here friends, what will happen? So here acceleration is equal to minus 18 by 2 second and 1 kilometer per hour is how much? 5 upon 18 meter per second. Meter per second. So here friends, 18 and 18 will be cancelled out and 2.5. So here friends, your acceleration will be how much? Minus 2.5 meter per second square. This is your retardation, negative acceleration. So in this way, you have to solve the problem. I think it is coming out to be yes, 2.5 meter per second. This is retardation, negative acceleration. Option next, 13th. 13th is also a very good problem. A car accelerates at a rate of 5 meter per second square. Find the increase in its velocity in 2 seconds. So here friends, we have to solve this problem. Problem number 13. So here friends, acceleration is equal to how much? Velocity upon time. And acceleration is how much? 5 meter per second square. And time is how much? 2 seconds. So V is equal to A into T, acceleration into time. So 5 into 2, it will be equal to how much? 10 meter per second. So in this way, you have to solve this problem. Problem number 13. Now next, problem number 14. See. 14th. What they are saying in problem number 14. 3 problems left only for today. See. A car is moving with a velocity of 20 meter per second. The brakes are applied to retard it at a rate of 2 meter per second square. This is acceleration. Just check the units. And what will be the velocity after 5 seconds of applying the brakes? So here, friends, what is initial velocity here? You have to see initial and final velocity, and we have to apply the formula. So here, friends, here initial velocity is 20 meter per second. Here initial velocity is 20 meter per second, and acceleration is 2 meter per second square, and you have to find velocity after 5 seconds. So time is here 5 seconds. So here, friends, we'll proceed for the solution. So A is equal to V minus U upon T. Initial velocity is how much? Here, 20 meter per second. This is initial velocity. It is 20 meter per second. This is initial velocity. And final velocity, you have to calculate. And time is given how much? Time is 5 seconds. You have to find the velocity after 5 seconds. So students, here A is equal to, I think that acceleration is also given, and it is given 2 meter per second. Acceleration is 2 meter per second square. It is also given your acceleration 2 meter per second square. Now we'll proceed for the solution. Here 2 meter per second square, it is equal to V. Initial velocity is 20 meter per second, and time is how much? 2 seconds. 2 seconds. So it will be equal to how much? V minus 20 meter per second square. It is equal to 2 into 2. It will be 4 meter per second. And students, here, if you will calculate it, sorry, here. Your time is how much? 5 seconds. Sorry, your time is 5 seconds. Your time is 5 seconds, not 2 seconds. So I was saying time is 5 seconds. Here, correct it here also. Time is 5 seconds. 5 seconds. So now here, students, if you will calculate, here it will come out to be how much? 10 meter per second square. Here it will be 10 meter per second square. Is this clear? And students, here your acceleration is retardation. So here your acceleration will be minus 2 meter per second square. So here it will be minus 10 meter per second square. So here, friends, if you will calculate it, it will be how much? Your velocity will come out to be how much? 20 minus 10. So it will be 10 meter per second. And here it is meter per second. So here you will get 10 meter per second. So this is the solution of this problem. See here, it is 10 meter per second. So the answer is correct. Now come to problem number 50. Problem number 50. So see, what is problem number 15? See what is given. A bicycle initial moving with velocity 5 meter per second accelerates for 5 seconds at a rate of 2 meter per second square. What will be its final velocity? So here, friend, this is also very simple. Your initial velocity is given how much? 5 meter per second. Time is given 5 seconds. Acceleration is given 2 meter per second square. And you have to find its final velocity. So A is equal to how much? V minus U. So it will be V minus U. V minus U. U is how much? 5 meter per second. 5 meter per second. Time is how much? Time is given 5 second. 5 second. Acceleration is also given. How much? 2 meter per second square. 2 meter per second square. So here students, what will be your answer? V minus 5, it will be equal to 10 and V is equal to 15 meter per second. So your velocity will be equal to how much? 15 meter per second. This is the solution of this problem. Now next, last problem of this lecture. See, a car is moving in a straight line with a speed of 18 km per hour. It is stopped in 5 seconds by applying the brakes. You have to find the speed of car in meter per second, the retardation and the speed of the car after 2 seconds of applying the brakes. So for students, you have to calculate the speed of the car in meter per second. Speed is given in kilometer per hour. So in meter per second, what you will do? 18 kilometer per hour. If you will convert, you will multiply into meter per second, you will multiply by 5 upon 18 meter upon second. So it will be how much? 5 meter per second. This is the answer. Now, student, next you have to calculate the retardation. Next, you have to calculate the retardation. So see how to calculate it. Retardation you have to calculate now. So see, how much is initial velocity here? Initial velocity is 5 meter per second. Final velocity is how much? 0. And students, time is how much? 5 seconds. Time is how much? It is 5 seconds. So students, you have to calculate acceleration. A is equal to V minus U upon T. So see, V0, 0 minus 5 meter per second. And time is how much? Also 5 seconds. So your retardation will be how much? Here. Retardation will be how much? Minus 1 meter per second square. Is clear? Now, friend, next you have to calculate the speed of car after 2 seconds of applying the brakes. You have to calculate the speed of car after 2 seconds of applying the brakes. To see how to calculate it. So time they have changed and they are asking to calculate the speed. Means they have given you acceleration. So you will put here acceleration as minus 1 meter per second square. So see, A is equal to how much? V minus U upon T. So your acceleration is how much? Minus 1 meter per second square. Is this clear? You have to calculate the speed of the car after 2 seconds of applying the brakes. So you have to calculate final velocity V. Initial velocity is how much? 5 meter per second. And time is how much? 2 seconds. To see, V minus 5 meter per second, it is equal to how much? Minus 2 meter per second. So your V will be how much? 5 minus 5 minus 2 meter per second. So your final speed will be how much? 3 meter per second. So this is the correct answer for this. So high, and the answer is also matching. It is 3 meter per second. So student, this is the solution. All the problems related to speed, velocity, and acceleration in one dimension. Next lecture, students, we will talk about slope. We will study about slope. So this is the final lecture by me. If you have liked my teaching method, then you can like, share, and subscribe my YouTube channel. That's all. Thank you.